Good morning everybody, or rather it's morning here. This is the video today is about probably the last and the follow-up to the 800 watt VFD air cooled spindle. I've tested it a few times now on various things. It's absolutely brilliant. It's ultra quiet, no vibration. Well, it's ultra quiet for me compared to what I was running. It just does the job, and for what it costs, I think it's absolute brilliant upgrade to the 4040. I have used it, as I said, on a couple of projects, but I've got a project on today that I'm going to show you set up and it running, and I'll probably go through it. I skipped through it a bit until the finished product, and it's the one that I'm doing is actually the Commando Dagger. I'm doing it. I've got to do one for Oaking someday, and that's the carving. Obviously the gentleman that I'm sending this to, he's actually adding it to something else at the side, a badge and a nameplate. He's cutting this off, and whatever he's doing with it, it's not, that's exactly how he wanted it on that, and I'm doing one for Oak for him. So whatever he's got in mind, it's fine. It's nothing to do with me. I did ask it for permission to show this, and he said yes, it's fine, because it is his. It's my design, but it's his idea, and I wouldn't want to put anything on that's somebody else's idea without permission. So I've done that. The motor, I mean, you can. I've tried some deep cuts with it, and it just plows through it. It's very, very good. But as I say, it's probably the biggest one you really want to put on the standard 4040 Pro, not one with the upgraded X-axis. This is the first ones that came out, so it's had the Z-axis upgraded because of the bearings that kept falling out. It weren't strong enough, and this seems to be working well on this. So yeah, but what I'll do is I'll show you operating, and just basically set up the job and show you what I do, and then I'll follow it from there. It's the actual 4040 is, there's many things you can upgrade with, and as you well know, I use the offline controller and the MPG. You tether it to a machine. I don't need to see where it's going round. However, I have been having some slight issues with the offline controller, the one that you get from Sainsmart, and that is what they call whiting out of the screen. It's operating, it's going through its toolpath, and you don't know when it's going to do it. It'll suddenly go to a blank screen. It still does the, don't be worried about it if you get it like that, it will still follow the actual toolpath. Mine continued to the end, but I could not get that screen back. The only way I got the screen back was disconnect it and plug it back in again. Well, obviously I couldn't do that mid-running because it's running from the chip. So, but it still completes its toolpath, and it's done it about 3 times on me now, and I don't like that. It does the job, but it's cheap and plasticky to me. It wasn't expensive. I think they're about £45 now you can get them for, but it does its job. If that's only what you can afford, then fine. People like them tethering to the machine, as I've said in previous videos. The only problem with that is you get a dropout on your machine, then you are or your PC, it will, you know, it will stop that CNC because it's working from it. It's transferring information. It can stop you in mid-process. So I don't like that. I like them being self-contained, really, if you want a better word. But it is a machine. It is a desktop machine. It isn't a pro machine. So treat it with that respect, don't try and push it beyond what it's capable of doing, and the machine will do very, very well for most people. My Pro machine here, the big one that my printers are sat on, it'll do anything you throw at it. If it stops or does something wrong, it's because you've programmed it. That's the only thing. You know, I can put quite large bits in that and it don't falter it. It just carries on doing it, and it's all ball screw, big ball screw shafts, so you know, it's a different, the 4040 is completely different to the Pro machine, so please treat them with respect, that it's a desktop hobby machine really. That's it. I'm going to take you over to the machine and I'll show you how I set it up to do the initial job, and then we'll set it running and leave it cutting. Right, here we are at the machine. It's fired up. The VFD in its own housing's on, ready for the spindle. I've plugged in my touch probe, touch off probe. I'm going to go to on the controller now to probe to touch off. It's already been centered on the job, so it's on the pins. So all I have to do is touch this off, install the program, and then let it run and just see where it goes from there. Okay, now one thing I would advise everybody to do is when you get your probe, and I've had one or two people say that because you're using this constantly, this flimsy cable, they've had one of the cables broke. It's lit up, but when they come to touch off, it hasn't stopped it. So when you using your probe, always just, if it goes to red, it's going to work. If it doesn't, then it's not going to work when it touches off, and you'll end up burrowing that into that. Okay, so it's just a point of order. Just make sure that that's on. Go to probe and touch off. You'll see it go to red. There we go. So that's touched off now. So I can disconnect mine. Beauty about it. Put it back in the housing. Right, I'm going to install the program now. Start project. And what I do is I always make sure that everything's at 00, so I just X and Y, don't do Z because you've touched off, but I always make sure that that's zeroed, which it is. Now I'll pick up the file, and the file I want is 3D roughing fast. Okay, go down to get ready to play, and once I press that, that will then go over there and start to cut. Okay, switch the spindle on. Then let's crack on. Right, I've backed away from the machine just to get so you can hear me a little bit better. Now, it's cutting at the moment, and on this particular one, I've done a 40% passover on roughing cut, because the small ball nose that I'll be using on the finishing pass will take that ultra smooth, and it does that in one pass. This will take a few passes, but the other thing about it as well is that on the each pass it clears the side. That's just because I've set a boundary box on the software program. Okay, and it's going down just under 2 mil each time. I would have a dust shoe on, as I repeatedly say on my videos. haven't got the dust shoe on the vacuum because I need you to see what it's doing. Now it'll leave it, as you can see on that, it'll leave like little lines on it. If I did that at a 10% passover, that's overlap of the cutters, it'll be ultra smooth. You could really, with that 4mm ball nose bit, you could even get it to virtually finish it, providing it goes into some of the areas. I've left 0.3 of a millimetre on the roughing bit for the final pass. So, and it'll continue doing that, and I have no problems whatsoever. It'll finish the program, and then I'll just change over. It'll go back to job 0. I'll take the bit out, and then I'll move the machine over to the end of the stock where it's the original thickness, and then and if I don't have that, I will have a spacer block that I can move the machine to. I'll put the new bit in, I will touch off, and then you don't move the spindle back, you actually just run the next software program, do the toolpath. That will then send it straight back to job origin and start from there. Okay? You can just see now where it's getting down to the actual, if you look at it, you can just see the knurling on the handle of the dagger coming through. As you can see now, it's actually going nicely. It's on its 4th pass now. Now what you can see there is on the other side of that is a replica identical to what it's carving now. I've never tried this before, but in order to I'm just hoping I've left enough on that when it machines it off, it actually keeps it on the final pass, and you end up with a full 3D model. Now if you look at the back, I'll just point out there are 2 pieces of material that are just mitre locked down to the base and to the side, and that gives it some stability, because if you've nothing on the underside and you're going thin, you'll get a lot of vibration that vibration can alter the actual because of the actual wavelength of the machine and everything. It'll resonate on the thin material as it gets thinner, and it can make it go up and down, so you can end up with an uneven cut. So as I say, this is a 40% pass over, and I'm doing this really because I just want to show it how quick it is and how easy it cuts it. I would normally do about a 15 to 20% pass over, and it'd be a lot quieter than that. Plus it's not a new bit, it did the other one on the other side, so. Finishing another pass. I would normally use the model boundary on something like this where I'm reversing it over because it gives support on either side, but I've done it this way for the roughing cut. All being well, I hope it works out okay. I've never tried this before, and it's mainly so you can see the model appearing, because if you do the boundary cut, it's inset. It's like the first one I did for somebody that was creating a mould. So I'm just doing this. I'm hoping it works and it leaves enough on to hold the model. Then when I do the final pass with the 3mm ball nose, when I do the final pass with a, I think it's either 1.5 or 2mm ball nose, then what I'll do is, that's done to the model boundary, so it'll just go around where the boundary is, all being well, leaving enough on to hold the model. Don't know, it's suck it and see. Never tried it this way before, so it's normally I do it model boundary, as I was saying. I'm just hoping it doesn't get, I've left enough on to keep it supported all the way around. Then when it does model boundary, it will plunge through, and then once I've done that, I can, as it's working along, all I do then is I normally put a bit of hot glue on the model at one end, and that keeps it in place. According to the offline controller, the time on it is 1 hour 42 minutes at the moment for this roughing pass, but it's never accurate, is that, because it gives you the time on your program and your software program, and it's never the same. So Yeah, what I've done with this one, this is the finished toolpath, but there's two finished toolpaths. I've altered them somewhat now. It's really, I'm trying this on the fly really, seeing which best way forward. I've done a boundary finish pass on this. Now there's 3.3 of a millimetre it left on the roughing toolpath, but I feel because the actual material is only very thin, and I've only left probably 0.1 so that I can clean that off at the end, because obviously it's a blade type, and then the final pass will be I'll do to the vector boundary, which will then cut it down a little bit further, but right across. It'll raster it right across. I'm hoping that relieves the pressure on that thin material. I don't know, so it's suck it and see, as a lot of the times it's experimental this. It's easy, absolutely easy to do just a carving of it, but I'm hoping I can get probably a 3D model with very little cleaning up to do. So let's see. You can see this now on its final toolpath, where I've done to do this, I've drawn a vector round so it doesn't cover all what's been machined before, but yet it'll go down to a finished path, and you can see it just slightly leaving a little bit on in places. I'm hoping it leaves a little bit more on that I can just break off and then clean up. But this side, you'll see that what I intend on doing is every so often all the way around I'm going to attach that with just hot glue. I've hot glued it at the top, there you can see it, so that'll hold the model in place at the end, and I'll do it ever so many spots all the way down. Hoping that'll do it. As I say, it's suck it and see when you're doing a model, reversing it. It's not as though you've got any material in between. Like if you were doing a coin, you could do one side, flick it over and do the other side. You've still a bit left in the middle. This has to go near enough all the way through. So we'll see. It's a project I wanted to try. And we'll see how it goes. I could do it probably on the rotary axis, the 4th axis, but I don't know. That's probably one to try in the future. Well, it's still going well. What you can see where the hot glue is, because the edges are so thin, I've just hot glued them to stabilise the vibration, that's all, and it's doing quite well actually. It'll just pick off. I'll just warm it up afterwards and just pick it off. But yeah, you can see where the handle has actually come through. So it's held at the pommel end, at this end I believe they call it, and just down the guard either end, and then just down the blade length. I mean, it is wafer thin. So to say that this machine's doing the cutting wafer thin like it is, you've got to be pleased with it. 2/3 of the way completed. Once it's finished, I'll then show you the actual job completed. Yeah, if with this project that I hadn't wanted to show you as it was taken down, I wouldn't have machined it like this. I'd have put a complete block down there and done a roughing toolpath, but I would have drawn a freehand boundary box round the model, close as I could. Probably leave about 3 or 4 mil around the outside of the model, the shape of the dagger, and then I would have machined that to the boundary box and rastered it 3D, and then that would have been the roughing cut. And then the first pass of the finish pass, because there's 2 passes, there's 2 tool paths for the finish. The first one I would do to the model boundary. That would take it down to a little bit off the top, but leave the sides slightly higher, which gives me then on the finish tool path, I go back to the boundary tool path, which is not the model one. That then, what that does is it takes it down to the finish then. There we are, job complete. As you can see, that's one side, that's the other side. All I have to do now is clean that up, and we'll see how it goes from there. Right, back up from the workshop now, and I said that I would show you the finished item. Now, this project that I've done was sort of a suck it and see for me. There's been quite a bit of learning curve from it, but to be fair, I'm over the moon with what it's produced, and it just goes to show the accuracy of this machine, because you're working with, on parts of the blade, you're working with something that's a millimetre thick. Now, I did show you in the video how I had to support that, and I supported it with hot glue. Cuts out vibration, and it supports that. It stops the cut of pushing the wood as it's cutting. Now, if you like put it like paper and you try to cut it, or thin card, it would push on it before it cut. So, and you didn't want any of that, so I had to support it along the way, as you saw in the video. And yes, there's probably about 3 ways you could do that, but this was just a project that I wanted to do. As you're well aware, I did the knives, the daggers, on as you can see, that's done on the 3D printer, and it's absolutely spot on. You can't fault it, and the blade's quite strong. That's on a 3D printer, and it's exact, more or less to scale replica. Okay, I did quite a few of those and they all come off. I used the same file for that in order to import it into Vectrix Aspire, and I created the toolpaths from there in the drawings. And as I explained in the drawing, there's different ways of doing it. There's no hard and fast rule with it, but what you must do is you must work off a center line. That is imperative, a center line. And on one occasion I lost the coordinates for whatever reason. It was machining, and I thought it had just started at one end on another pass of the roughing tool pass. I didn't put it into the video, and it actually shows. I think I kicked the extension that the machine was plugged into, and for some reason the plug came out and it stopped dead. But I'd taken the coordinates for the job origin. Okay, so excuse me, all I did was fired the machine back up, sent it to home because I'd lost everything, sent it to home, and then excuse me, and then once I'd homed it, zeroed, and I sent it then to the coordinates that were originally set, zeroed off again, and it picked up exactly where it left off. I just had to wait for a little bit while it started machining again. It was machining thin air because it was just going over something that had already been machined, but it was only about 20 minutes in, fortunately, and it just carried on. Now, when you're working with jig and pin, you'll find out that if you're working with a center line, and I mean it's crucial to get that center spot on, when you flick it over, if it's not spot on, that center line, that cutter, then you will get an overlap. It'll be offset with the next model that you do. Believe it or not, when I did this, when I flicked it over and I eventually took the rough away, I've already done that, it was, I would say, less than half a mil. It was just a thin piece that I could tear off. I couldn't believe it, and that's the accuracy of the machine when you treat it with respect and not try to take off large amounts. I'm sure the 800 watt spindle had something to do with it, because it just run and run and run. Fair few hours work on this project, and it didn't overheat, it never faltered, and I could alter the speed on the fly to what I wanted. It's really good, and I would highly recommend that spindle motor for that machine. I mean, to say that it's got lead screws that aren't ball screw, it's not bad. Just anti-backlash. Ball screws are more accurate. My Pro machine's really accurate, but for what it costs, it does a fantastic job. But it's when you watch the video, and I can't cut the video down into make it too short, but I will try and put in as much as I can of the machining. I'm not putting sound on over the machining. It is what it is. The only downfall is that I have to keep, in between the video recording, I have to keep vacuuming the dust away. I would normally have a dust shoe on and a fine hose from that, but I wouldn't have been able to show you. But the there was various ways, and I do explain the various ways that you can actually machine that. I'm not going to go through it here, but I'm sure you'd all like to see the finished product. There we go, the finished product. That's, look at that, that's the file. That's, as you can see, I'll spin it round, and the blade, you can see the blade, look how thin that blade is, that it's printed, and it's printed it well. The actual detail on it, it's pretty good, as you can see. Now this is identical. This is the timber one that I took off the CNC. This is American white oak, and I'll show you the, and I'm picking it up by the blade tip so you can tell the detail on that, and the guard, the hand guard, both sides, and just look at the blade there. That's the face on, that's both sides, you can see the detail. Look at the thinness of that, and what's more, the blade is ridged in the center. You can see that there. You see the ridge? That goes all the way to the tip, virtually. You can see that. And I'll just show you how strong the blade is. Look. The detail is incredible, and I don't know, I've left a little bit for you to see these just slightly out of line. You can, I don't know whether you can see that. See if I can get it in focus. Just on the end of the, I believe they call it a pummel or whatever it is, you can just see there. I'll mark it there. Wait a minute, see if I can do it down here any better. Where my finger is, you can just see the step over there. That's how much it was out, negligible. So yeah, it was a project well worth doing. I altered things along the way, and because I could do that, and I know my way around this fire for what I use it for. Yeah, it's I'm really pleased. So that's the end of this project. Keep your eye out. I'll just flick it back around. Keep your eye out for the video on the Nemo Labs or Nemo Labs offline controller that I've got. I'll show you how I've mounted it to the machine, or how it's going to be mounted, and I'll show you it working. And watch the video on that. So I'll put a link at the end of this video to so you can watch it. It's well worth looking at, as opposed to spending £49 on that offline controller that you've got down there for less than another £100. Well, I'll tell you the price of it. It was £136 from Amazon, and it came within 5 days. And when you, I can't show how it feels on the video, but when you pick the unit up, it is so well made. I was amazed. I thought it'd be a bit of plastic. No, it looks like it's machined aluminium housing. It's really well made. But watch out for that video. So if you want it, click that notification, and don't forget like and subscribe, because it means it helps my channel. It doesn't cost anything, and for some reason I keep losing subscribers, and then they come back, and then they lose them, and then they come back, and by all accounts it's something that's happening within YouTube. I have no idea. as I say, I don't upload videos to make money out of this. I'll just help. I'm hoping I'm helping people out there. Just show what you can do with these desktop CNCs. You know, you can all do flat items and V-carve and inlays, but when you're doing something like that, that's a 3D. But it's as I say, it's done with jig and pin. And you've got to be accurate with your setting up of this. So yeah, so well, that's it for end of video. So don't forget, like and subscribe, and please, any comments I will try and answer you. If I can help you in any way whatsoever, I will do. I can't help everybody because I don't know a lot of some of the technical details that some people put towards me, so it goes over the top of my head. But I look into it and they're right what they're saying, but it's very technical, some of it. You can do this, you can do that, and they quote figures at me, and I think, yep, I'm not going to argue with that. He obviously knows more than I do. But yeah, so we're all learning out there. And the one thing I will say is, treat the desktop machines with a little bit of respect. Don't try and do things on them that the machine's not capable of doing, because it will put you off, or you'll break something, or you have an accident. Treat them with respect. They will take your fingers off. They can ping a cutter and break it, and that cutter can end up coming out at you. As I already said, didn't I, in one of my videos, what happened with me. So do be careful. Right, that's it for end of this video. So as I always say at the end of every video, for God's sake, what's happening now in the world is it's worrying, let's say the least. So everybody be careful, be vigilant, and of your surroundings and everything, what's going on around you, and look after yourselves. So until next time, you have a great day, fantastic day, and I'll see you in the next one. So bye for now. Bye.